Today I'm going to explain what a rotary laser can do and what it is for use. So first of all, as you see, it rotates a beam. This is the DC-80, and with the 80 version you can work up to 600 meters, really nice for highway or big excavations of ground and that kind of stuff. So first of all, to know what a laser is doing, it has a straight water level line. You can work in slope, one axis, or even in double axis. So that's possible with the Series 80 version, and this version can also work with Bluetooth. So with Bluetooth you can work up to 300 meters maximum in an open area, and that means that you can work with a phone and give the information to the rotary and also the information back. So when you're standing on 300 meters, you want to work in a type of slope, in a kind of percentage or degrees. This app allows you to do this. For that 300 meters distance, you need this receiver, because this is the Bluetooth and this unit makes connection with the rotary lasers. So you have to pair them. If you do not do that, you will work only on the rotary. It works to 30 meters, not further than that. But first of all, I want to measure a height of a box to show you how it works in big distance. So what you're going to do, you switch on the laser, the detector, sorry, you line it up with the 0 position. You fix the screw and then the clamp. It's better with the screw because then you're really secure with millimeters. So first of all, what I'm going to do, I have the full sound. So that means I have the line leveled, and now I want to measure the height of a box. So I use this box. I put it on the top of the box, and what I'm going to do, this one, it stays like it is. I'm just going from this one moving. So what I'm going to do is move it, going down till I get the fully sound. I have a screen on the back so I can see what it is. And there we go. Now I can read how far or how high the box is, and I can see that over here. You see a plus 13,5. So this box is 13.5 millimeters high. So this is already nice knowledge that you can see. If I go back to the 0 position, and I want to have a slope of 1%, you're going to stand 1 meter from the laser away. You put it on 0 first, and now I want to have 1% over 100 meters. So what I'm going to do, I put it on 1 centimeter up or down, depends which angle you're going to. And then you're using the x-axis or the y-axis. Right now the x-axis is selected, and on the top you can see which axis you're working on. So the x-axis is this one. If I'm correct? No, sorry, the x-axis is this one. That means I can move that way or this way. With the arrows I can move, and I keep this detector 1 meter away and 1 centimeter up, and I can keep on pushing the button. I can do it with the remote, I can do it with the Bluetooth connection, and then I'm going to see if it's going up or down. Right now I push down, that means the laser beam is going up there and down over here. I work up. Right now I can go down to plus 1, and he's saying opposite, so I have a little bit going back up till I get the full sound. If I'm there, then I have 1% over 100. So in 1 meter, that means 0.1% over 1 meter. Over 2 meters, 0.2 millimeters percentage over 100 meters. So that's how it works when you do it manually. But it's of course nice when you're standing far away and you have a kind of slope. You just push the button and the laser is looking where you are. And then you can read what kind of slope the building is already built on, or what kind of slope you have to fill on the ground or escalate everything. That's really fast way of working than I do right now. So that's the first thing that you can do. This is a single slope. If you press the other button, you got the double slope. What does that mean is that you have one angle right now to my side, and I want to have the other angle to the other side. You're going to use the y-axis and press again to this button. What you're going to use then is that the water flow is going to one corner, and not just to one angle, it's going to the corner. Then we have the RPM button. The RPMs are really important for really escalating material, big trucks that are driving around. Why is this really important? The speed of the car, or the van, or the escalator is driving, let's say 25 kilometers per hour. That means that the speed of the rotation should be higher, otherwise you cannot follow the line. There are detectors that work with a big magnet that stick to the escalator and that fill up the ground or going up and down the ground. That need the speed. If their speed is higher than 1200 RPMs a minute, even better. Even higher, 2200, there are lasers in the market that does it, and that's really useful. But for indoor use, you have mostly working on 150 RPMs. You're going to see the beam even better for indoor use. Then we have 300 meters, 300 RPMs, and 600. Mostly you're working on 600 RPMs. Then we have the scan mode. The scan mode is mostly used for indoor. As you see, it's the scan mode. It's a 15 degrees, 45 degrees, or 90 degrees. And this function you cannot use with a detector. It should be useful when you can work with a detector, but they need the speed of the rotation. So right now I cannot use it, but it's really useful if it is possible. Why? Because, for example, there are glasses around this side, and this side I have to work. If there are glasses and the rotation laser is turning on, the mirroring of the glass goes back in my detector, and he doesn't know which kind of line he has to use, so he doesn't know the level. So that's why it's useful to use a scan mode with the function on the detector. There are brands who does it. They let the rotation, the laser rotate, and they're switching on and off the diode quickly. So on the piece where you want to work, the diode is on, and the pieces of the glass, the diode is off. It's really useful that the rotation laser can do for outdoor use. This other functions that you can do is, of course, a vertically mode. But that's, I think, maybe too difficult, but I'm going to try to explain quite quickly. So, within the wall, once you have the legs, that makes sense because when you switch on the laser vertically, he first levels the laser. And when he's leveled, he's turning and he's dotting it down. So you can put it on the mark where you want to work on. When you put it on the mark where you work on, you can go on the other side of the building, 300 to 600 meters, and put a mark as well on the ground and put a detector over there so you can line it up. So he's putting it down now. I press on the RPM button and he starts rotating. Now I'm going to go on the other side of the building. Depends on the distance, of course, 100 meters, 300 meters maximum. I lay the detector on the ground. So I disconnect it and I put it on the ground. And what I can do, I can do it manually, of course. I can move the laser manually. But if you are working on a big distance, this is not really easy. So that's why you're using the arrows again on the bottom and say going up or down. Again, if you have automatically beam search or beam finder, you just press on the button and the laser is looking for the detector and he found it. It's quite fast working, and this application normally you use two people for. One is at the detector because you cannot hear the sound of 300 meters, and right now we can do it with the app with this version if you are in open field at maximum 300 meters. So, what can you do else with the vertical mode? We have the dot up and we have the dot down. The down is red because it's much cheaper, of course, and we do not go so far as a green one. With this one, it's a straight angle all the time. So if I move my axis to the left, the dot is going also to there, and the down dot is going that way. So it's always a straight angle, always. So if you want to work in a big field, and you want to make a big square of 600 meters that way and 300 meters this way, or 150 meters, doesn't matter. What you're going to do is you put the detector again on the way, like I just showed, for this application, because the detector can detect the rotation flag, but not the dots. And in that case, I put one piece of wood in the ground, on the front, on the back, and on this side. And I mark all my points, and then I go to that way and mark it over there on a piece of wood. Over then I turn my laser and put the marks again lining up with the laser and take this piece of wood away and go that way with my detector and mark it again on that piece of wood. So that's how you can work as well on the straight angle. It's really nice. If you work with a 3x360, you have these angles, of course. You see the 3x9s. Only when it's 3x9s, you cannot work higher than 100 meters. So you have a problem, and the accuracy is not that well as a rotation laser, of course. So this is a nice feature if you have an automatic fine grain beam. So you put it on a piece of corner and you just press a button. You do not need an extra person who stands with your laser, or you shouldn't go back and forward to check if it's okay. Then the old rotation laser has the platform, XR platform, but it's really nice. It has a tripod connection with the butterflies, really useful because if it drops on a tripod, it disconnects and the rotation can drop can hit the drop and doesn't damage it so hard as it's connected completely on the tripod because it can break out of the chassis. So that's another really nice feature on this one. Back to the detector. The detector has a really nice slide system. So it's a click system, really useful. We use it the same as the line lasers. I cannot find it. The detector of the line lasers, sorry. It's the same version. We make a switch up, really nice. So keep this going. But it should be also nice when you can use the same system on the rotary. So you slide it on and it's always sticking to the rotary when you hide it in a box or so. For the rest, the detector window is quite small. It should be much bigger, like a millimeter scale detection. It's really nice to have. And what else? The speaker, it's not so loud of this one. It should be louder, and an LED, of course, to show you how far you are off the beam. Some features are really nice to have because when you are really high, you cannot see the detector so well. You can follow the LEDs, or you can go on sound on the bottom of the unit. That's a really nice feature. So that's how rotation works, what you can do with it, and some benefits, what we can improve with our walls.